care of it. All right. So we are going to talk about a specialized way to do double replacement reactions. Okay. So when we do double replacement reactions, let's kind of talk here about really what's happening in terms of a double replacement reaction. Okay. So when I have, and don't write anything down yet, just let me talk about this, okay? When we have something like sodium chromate here, okay? This. I'm going to give myself a little more room to draw here. So when we talk about sodium chromate is Na2CrO4. It's going to come together with zinc sulfate. And really, I should.
Oh, that's very, I wasn't expecting. What?
Do the wrinkle. Yeah, I want this.
Yeah, we tried to color.
Okay, so this is what is happening there. Then we are going to, oops, that isn't dark enough. It's too black. Yeah, it's supposed to be like a colored pencil. Okay, so then we're going to swap partners, right? We've got our zinc here. He's going to stay in his house. Our sulfate is going to come over here, though, and he's going to start living with the sodium. Have to reevaluate our charges. This is a +1 -2, so I need 2 of these. And then my chromate is going to come over here and be with the zinc. +2 -2. Don't have to change anything with our charges there, subscripts. Okay? So when this happens, we consult then our solubility chart. So remember, this guy is going to stay aqueous because he's soluble. I don't like that pencil. I'm switching out of that. I don't like that. Yep, I don't like it.
Can you show me one?
Here, I'll just do this. AQ, okay? And this guy, if we flip over our solubility chart, they talk in number 9 about chromates. And chromates are usually insoluble, which means they're going to form a solid. Okay? Yeah.
How would you go about knowing if it was not insoluble?
Pretty much anytime you get a chromate on this side, it's going to be soluble.
Okay, so don't worry about it.
It's going to be a solid, I mean. Yeah. So what we tell kids, so in AP, you don't get a solubility chart. Hold on, chill, okay? You have to memorize 4 things. Sodium, nitrate, ammonia, and potassium. Pretty much any time that these are with one of these other things, it's going to be soluble. Anything else, those are the only solubility rules that you need to know in AP. Okay? So you can assume that if sodium is with something, it's going to be soluble. If nitrate is with something, it's going to be soluble. If ammonia is with something, it's going to be soluble if potassium is. And if you look at your solubility chart with those things, it's pretty much everything there is going to be S's all the way across or down, depending on where you're looking. If it's a nitrate, you're going down. Okay, so that's all you have to memorize for AP. So, and it's a snap, right? See?
Yeah.
And it's actually faster than consulting a solubility chart, really. You know, so in a way, it's kind of nicer. They don't give you a whole chart to have to look at. Okay, so is everybody following me with this whole mess here? All right, so let's look and see what's happening in our separate little test tubes, so to speak, okay? So here I've got a test tube with this stuff in it. Here I've got a separate test tube with this stuff in it, and then I'm going to bring all of this stuff together in one test tube. Okay? So before the reaction happens, these two things are my reactants. They're in separate test tubes. My sodium is going to be floating around as an ion because it is aqueous. So remember, this is aqueous, and what aqueous means is that they're floating around and they're separate little ions. Okay? Does that make sense? My chromate is going to be floating around in its separate little ion as well. Okay?
Can we draw these diagrams?
If you really want to. But I'd rather you just pay attention to what I'm talking about right now. My zinc is going to be floating around as well. Okay? And so is my sulfate. Okay? I should go back over here and make everything kind of equal in amounts. So give me 1 second to put one more chromate over here and a couple more sodiums. I cram him in there. Okay. All right. So now I'm going to bring these things over and I'm going to put them all over here. We're going to mix them all together. Okay. So now I've still got my sodium floating around because it's aqueous. I've got 4 of those floating around. I also have my sulfates floating around. But what has happened to these guys?
Solids. They're precipitate.
Okay, so yeah, they are a solid, so they're going to be down here at the bottom. And in this, they've kind of dropped out. Okay, does that make sense?
Yeah.
So, has anything changed with the sodium and the sulfate? No, they're still as ions. Okay, do you see that? They're still floating around in this liquid. Nothing's changed about them. The only thing that's changed is that these have now become a precipitate or a solid. But nothing's happened to these guys. They're just kind of standing around watching this happen. So if you are at a game and you're just standing around watching the action, what are you called?
Spectator.
A spectator. So these are called spectator ions. Okay? Does that make sense what's happened?
Yeah.
Sorry? Okay. All right. So when we go through and we do these net ionics, I'm going to show you the long path first, and then I'll show you a shortcut. Okay?
You want us to write the actual?
Yes, write this stuff down. So write this down. I'm going to get rid of that pencil. I don't like that pencil. I'm sure that pencil has some sort of artistic value for some uses, but for us, it's not working out well. All right. This should be AQ here. Sorry, I got cut off when I was doing my racing. All right, we good? Any more time? So make sure that your equation is balanced. Okay, yep, this one balanced itself. All right, now we're gonna, anything that is aqueous, we are going to break out into ions. So rewrite equation with reactants and aqueous products as ions. So we're going to write 2Na plus AQ plus CrO4 AQ, and its charge is a 2 minus, plus Zn 2 plus AQ plus SO4 2 minus AQ. So I will wait for you all to get that jotted down, and then we'll go to the product side. Go to the dark side. Come with me, young Padawans. I know. I watch my Star Wars.
Weren't you the only one who teaches chemistry honors?
I am. Oh, yeah.
It's crazy how many classes of chemistry there are.
Well, I teach AP, so typically the people who fuel my AP come from my honors. So if I'm going to control my AP scores, I like to control my honors. So that is why I've asked to have the honors. And since I'm the only one that teaches all chem, everybody else teaches a bunch of different things. I'm the only one that teaches all chem. They kind of are like, yeah, we'll let you have honors. And then next year, honors is going to be transcripted. Regular chem will not, and I'm the only one that has the credentials for.
It's transcripted this year.
It is, but next year it won't be.
Oh, next year.
And I'm the only one that has the transcripted credentials. So it will squarely fall with me, unless somebody picks up those credentials between now and then. They hire somebody. So. All right. So now, when I get to the product side, okay, anything that's aqueous is still going to get broken out. So this is aqueous. I'm going to break that out into its ions because remember my drawing, this stuff is floating around. It's floating around in that water. But anything that's a gas, water, or a solid is going to stick together. And so you'll write that down. So make sure that your thing looks like my thing. Anybody need more time writing this down?
No,
You always thought that was my idea.
I can, but I didn't think we would need that much space. I'll write it down for the next one.
I had a girl that wrote so small a couple years ago, I actually had to get a magnifying glass out to read it.
That's pretty good.
That was crazy. I told her she had to write at least as big as the font on the page. And she wasn't doing that. It was tinier than this. All right. So now, anything that is exactly the same on both sides gets crossed out. Those are your spectators. They're just watching what's happening. So my sodium is the same on both sides. It's going to go away. My sulfate is the same on both sides, so it goes away. Then we rewrite what's left. I told you that I have a shortcut. I will show you on the next problem, okay?
Okay. I'm excited. I'll have super tiny for the next.
All right, so this is your net ionic equation here, because really, this is all that's going on.
So that's it?
That is your net ionic right there.
That's pretty good.
Because really, that's all that's happening. Nothing else is changing. Does that make sense?
That's what we needed to find out.
This is what you needed to find out, yes.
So we're kind of
That's
just
not
writing
bad.
it,
So now I'll show you the shorter cut. Yes.
so we're kind of just writing it as a synthesis over a double replacement. Kind of.
Yeah, I guess. Yeah, but I mean, you have to start with all of this stuff.
Yeah.
You know, so that's why. Yeah.
Okay.
Does iron 3 hydroxide form a solid? Iron 3 hydroxide. Yes. Okay. And we're good with this one. Okay. So this guy, NaOH, aqueous, plus FeCl3, aqueous, NaCl, aqueous. You probably don't need to look that one up. You got an ocean full of proof with that one, right? Salt water. Great Salt Lake. All right, so when you get comfortable doing this up here, all right, then you can start to take your shortcuts. We do need to balance this guy though, okay? So I'm gonna put a 3 here and a 3 here. So I've got him balanced now. Make sure you balance. You still gotta do that. All right. Okay, so you ready? Everybody ready? Good now? Okay, so now go through and identify. Okay, first of all, I had to put down that this was a solid. Sorry. Okay. Now, we're going to go up through and we're going to identify the parts over here that made this happen. Okay. So this is our solid. This is what we care about. We're going to find over here what made that. Does that make sense? So over here, this made that, and this did. Okay? So we're going to come over here now, and we're going to write those things down. So how many of these do I need? I need 3 OH minus. That's for these 3 right here. And I also need this guy, Fe. And what is his charge? 3 plus AQ. AQ. All right. So I don't really need to go through and write all of this out every time. You see what I mean? These are kind of like training wheels up here. If you can go here and you can figure out what made that happen, then just do the shortcut and get right to there. Get to getting. Does that make sense? Now, I'm one of the only people that teaches the shortcut. So if you get into college, they may make you go back and write all that jazz out. But I do it because when you get to me with AP, you're trying to save as much time as you can. And it's a big time save. And I think, like, why sit there and write all, I don't want to write all that out. Do you?
I know.
If you understand what's going on, you don't need to, really, right? Right. All right, so the only ones that you've got to be really careful with are the ones like here, where it's going to make, this guy ends up making H3, because remember this will end up making H3 or H2, sorry, bad looking. H2CO3, okay? If you get H2CO3, what do you have to do? Yep, get rid of that. You're going to get your H2O, and you're going to get your CO2. This is a gas, and this is a liquid. Remember, the only things that you cross out are aqueous. So these are going to be products. You're also going to form down here K3PO4. Okay? So these you're going to keep, and you need to find the stuff over here that made that. And you got to balance the thing. So you still got to write out the whole equation to start with, because you got to get it balanced. But that kind of gets you started on that one. Fair enough. Have I lost anybody?
Yeah.
I don't listen to him. All right.
Is this only our homework for the weekend?
Yeah, you have extra.
Okay, so that is your homework. Yes, your homework is 9-7. I need to look and see how many pages it is, because if I don't tell you it's more than one page, you might not keep going. It's 2 pages. You have 2 pages. Okay? How many problems do I need? 14. I did 2 of them, so you got 12 problems this weekend. It's 3 days to do 12 problems. That's 4 problems a day.
We just do nothing.
You've already got it done.
Well, there's no reaction.
Yeah.
All right.